So in this video, we're going to graph a logarithmic function that has been transformed by a bunch of things. And instead of using graphing transformations, we're going to use an algebraic method called key features. And what's nice about using key features is it just makes everything so much easier than graphing transformations. I mean, you might be looking at this right now and thinking, okay, what's going on here? We've got a horizontal horizontal reflection, right? That's going to be complicated. Then we've got a horizontal shift on top of that. And on top of that, we've got a vertical shift over here. So 3 different transformations, and we're going to graph this thing. What a mess, right? Well, it actually gets pretty easy when we're using an algebraic method. So for this, it's going to actually be, similar to what we were playing around with exponents, if you remember those previous videos on graphing exponents. And what I'm going to do here is, remember, I'm looking for key features. That means places where interesting things happen. So I think it's interesting when the argument of a logarithm is 0. I think that's an interesting place. So argument equals 0. Well, what's the argument? That is this thing, this negative x plus 1 inside the logarithm parentheses. So where does that equal 0? Well, that's going to be where, we divide each side by a negative sign. We just get x plus 1 equals 0. And that's where x equals negative 1. Okay, so what happens when the argument of a logarithm is 0? Well, if you remember the basic properties of logarithms, where the logarithm, and it doesn't matter what the base is, where the logarithm of an argument equals 0, the answer is basically DNE. Okay, you can't get that. Or another version of this answer is negative infinity. But either way, it's a DNE. And what DNAs usually look like are big asymptotes, right? It's one of those vertical lines that just goes up and down. So at x equals negative 1, we have a vertical asymptote. And that's always going to be the case. When your argument is 0, this produces your VA, your vertical asymptote. And that's one of the key features of a logarithmic graph. You always have this up and down line. Now, another key feature, another key feature is going to be where the argument equals 1, not 0, just 1. So we go through the same steps and we say negative x plus 1 equals 1. Okay, so that means x plus 1 equals negative 1, and that means x equals negative 2. Okay, now that's important. We don't stop here. Let's plug this value of x equals negative 2 back into our equation and see what y equals. So y equals log base 2 of, and remember what the argument is? 1. You don't need to spend a lot of time evaluating that. Minus 1. Well, what's this? Log, and it doesn't matter what the base is. If the argument is 1, the answer is always 0. So y equals 0 minus 1, and that's negative 1. Okay? So in other words, this has produced for us a point, an xy coordinate point, which is at x equals negative 2, y equals negative 1. And what we do is we come over to this graph, and we say, okay, there's x equals negative 2, here's x equals negative 1. We put this point on the graph. Okay? So now there's only one more thing to do. We've evaluated where the argument is 0. That's a vertical asymptote. We've evaluated where the argument equals 1. Okay, that is one of the xy points. And now we're going to evaluate where the argument equals the base. In other words, whatever the base value is of this logarithm, okay, in this case it's 2, but it could have been 5, it could have been 20. Whatever that base is, we're going to say the argument equals the base. So over here I'm going to say argument equals base, in this case 2. So our argument is negative x plus 1, and we're going to say that's equal to 2, which means x plus 1 equals negative 2, which means x equals negative 3. And now we can figure out the y value. So y equals logarithm base 2 of, remember what the argument is, it's just 2, minus 1. Now log base 2 of 2, in other words, 2 to what power? 2 2 to the what power equals 2? Well, the power is just 1. And any log, I'll write it this way, any log of any base where the argument is also the base is always going to be 1. That's one of your basic log properties. So what that means is we have y equals 1 minus 1, which is 0, meaning our xy coordinate point is -3, comma, 0. Okay? So we're going to plot that on our graph. And -3 is about here, and 0 is obvious, that's right there. And we're basically done. We can just connect the dots. So remember what a log function looks like. It starts way down low and just comes up high. So there's our log function. And the graph is now finished. And this is often easier than graphing by transformations because you can handle any number of transformations by this method, and it will always just be these 3 steps. You find the vertical asymptote, then you find one of the xy points, and then you find another xy point and connect the dots.